Hello. Hi. Today we are going to cover on system implementation strategies, which is partly covering on implementation phase. What will be covered in this slide is that we'll be covering on some of the diagrams, which is on implementation diagrams. However, in this slide, I'm not covering on it. It's actually related to component diagrams and also on deployment diagrams. The second content is on implementation conversion strategy. Okay, for this slide, I'll be covering more on the conversion strategy, and the remaining objective will be covered in part 3. Okay, as I've mentioned just now, before this, we have experience working on the analysis phase and also design phase. If I can recall, in software development life cycle, we started off with gathering requirement, okay, which is done during analysis, and then we do design, and now we are moving to the next phase, which is on implementation. Okay, implementation covers a lot of activities. Among those are the coding part, okay, where after you have done with the design part, the next phase is actually starting with the coding. Okay, it depends on whatever programming language that you have to use, Java, PHP, HTML, it depends. Okay, once you have convert your design into your coding, okay, next thing that you are going to do is that you need to do the testing part, okay, to make sure that everything works as expected. And after everything is running well and has been tested, the next phase is actually to do installation. Okay, installation is where you have the code ready and you want to install it at the customer site. Okay. All right, you want to basically turn over whatever that the user is actually currently using in their computer in the organization, and you want to install the new one that you are currently developing. Okay, basically there are 4 strategies on how to do it: direct, parallel, single location, or sometimes called as pilot, and the fourth phase is called phase. Let's look at the first one, which is called direct installation. So what happened here is that, let's say you go to the customer site, bringing along with the new software that you have developed for them. Okay. If they are currently having working system already, okay, which is, we call it as current system. Now you are going to install the new one that you have developed. Okay, once it is being installed, the new system will be running. The current one will no longer be used at all. Okay, what's the benefits of doing this kind of conversion strategy? The first one is that it brings immediate benefits. You can see the new benefits from the software straight away. And at the same time, it forces the entire user in that organization to use it. Okay, so they don't have any option whether to use the old one or the new one. And this kind of strategy is very simple, okay, straight away. And the disadvantage is that you can no longer fall back, meaning that if this new software is not working well as expected, you cannot go and use the old one already because it's no longer there. And you need to have contingency plan. So meaning that backup plan. What will happen if this new system is not running? So this kind of conversion strategy for installation is good if it's for a small scale system and it's a very low risk system. Okay, so for example, lorry system, for example, inventory system. Okay. Let's move on to the next strategy, which is called parallel conversion strategy. Okay, in this strategy, what will happen is that you run the new system, the one that you have just developed, with the current system that the organization is currently using. Okay, both are running at the same time. Okay, with this strategy, what happens is that, okay, once it is being installed, both systems are being running at the same time until the user are comfortable with it. Then the current system stop running, they run with the new one. Okay, the benefit is that if the new system is having problem or it's the logic is not running as expected, the user can fall back to the current system. Okay, the benefit is that because two systems are running at the same time, you can actually compare whether the new system actually produce results the same as the current system or better. Okay, uh, whereby because you are running two systems at the same time, of course, you are using lots of resources. You have to assign two group of people to work at the same job running on a different software. Okay, and at the same time, when you are using this approach, the user not committed. Okay, this kind of strategy is suitable for business critical and high risk system, meaning that for system which is having is a critical system, you want it to be running at the same time. Okay, in case anything not working well, you can straight away move to the current system. Okay, moving to the third strategy, which is called single location or sometimes being called as pilot approach. What you do in this strategy is that you choose to run the new system at one department or at one branch. Okay, so you run it there first, see how it goes, right? So if there are errors, you settle there only. Once it's already working well in one location, you install it to the entire organization. Okay? So this kind of strategy is good because it can be used as a learning experience in one department without affecting others. You can give feedback on the design. Okay, check what are the errors before you launch it to the organization. Right? So whatever decision that you do in one organization, sorry, on one unit or department, you can do it first at one unit before you implement it. Okay, so it is good because it reduces risk. On the other hand, it's not the disadvantage is that there is an initial cost. Okay, because you need to spend in one location first. Maybe the benefit is gained at that organization or sorry at that department first, but it's not experienced on the organization level. Okay, this kind of implementation strategy is good for small systems or package software. So, for example, you install package software is for example, okay, you install Microsoft Teams first at one school. For example, in the university, one school is actually using Microsoft Teams first. All the members at that school experience first, and when they feel it good and it's smooth, then it is being implemented across all schools in that university. Okay. Okay, the fourth strategy is called phase location. So what happened in this strategy is that current system is running and they install the first module first from the new system. Okay, and when it's done, so the current system, the existing system is running without that first module. Okay, and the new module from the new installed system will be running. After it's running and there is no error, it will install the second module, and the existing system still run but without module 1 and module 2. But this time around, module 1 and module 2 from the new system is running at the same time. It is like parallel strategy but being implemented phase by phase. Right? The good thing about this strategy is that you can pay attention to each module, see which module is really running well or not. Okay, subsystem or module with high return on investment, the most critical module for that organization can be used first or can be tried first. Right? And the bad thing about this approach is that if one of the modules is not running well, it will spread rumors across the organization. So people will having bad thoughts about that new module and the entire module. And then it takes a lot of time to get to see the benefits because you run first module, second module, and so on. So this kind of strategy is good for large system with independent subsystem. Right? So by now you have I have already described about 4 conversion strategy that you can apply during installation. Okay. And what are the key factors that the project manager decided in order to choose which strategy? Okay, among the factors are risk, cost, and also time. Okay, in terms of the risk, you should be thinking about the seriousness of consequences of remaining bugs, meaning that if there are errors happen, what will actually be affected. Okay? If you can compare between parallel and pilot, okay, parallel is considered to be less risky than direct. Okay, because when you do direct conversion, the current system is no longer there, but with parallel, it's still there, right? If error is detected at the new system, cannot be solved, you can fall back to the parallel, to the existing system. Another less risk approach is actually pilot, because what happens is that if there are errors happen, it only experienced in one unit or one department rather than entire organization. Alright, another factor that need to be considered in selecting which conversion strategy is term of the cost. Right? Cost refers to your staff salary, operation and communication hardware that you have to be made available when you choose that strategy. For example, if you use parallel, it's more expensive because you need to provide 2 sets of working staff, 2 sets of hardware, right, running at the same time. And the third factor is time. Okay, how much time that you have. Okay, if you have longer time, maybe you can use phase or parallel. But if you don't have enough time, maybe the best option that you can select is actually direct. All right. So hopefully this is beneficial for you. For the remaining content, you can get it from part 3 of this slide.